Number 9. Number 9 is actually now moving into topic 2. Everything we did before, that was all stuff from topic 1. Topic 2, we were focused on sequences. As we can see here, we reminded you guys with our formulas that we use. Now, primarily lately, we've been focusing on arithmetic sequences right here, okay? Now, actually, my bad, this one right here is primarily the one we've been using. But we are going to go back and check on both of these, arithmetic and geometric, both as a recursive and as an explicit. So let's get going here. All right, describe each pattern and state the value of the fourth term for each figure and tell me if it's infinite or finite. Infinite or finite, that should be the quick one. As we can tell, that keeps increasing, so that is continuing on, that's infinite. Letter B, you can tell we're decreasing, that is finite. All right, so this is the first term, this is the second term, this is the third term, and what I'd like to do then is say, hey, 1 here, 3 there, 5 there, and once I see 1, 3, 5, I'm trying to figure out how you're going from 1 to 3 to 5 and so on. So we keep adding on 2 circles, a plus 2, a plus 2. So then for the fourth term, we're going to have 7, adding 2 each. Now letter B, we are decreasing something. So this is the first term, the second term. We always read left to right, the third term, and then the fourth term. Okay. So I like to go ahead and just count up how many we got there. So let me zoom in just a bit. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Hopefully I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So from 25 to 16, how much are we decreasing from 25 to 16? We're going down by 9. How about from 16 to 9? We are going down by 7. So as we can see there, we are removing 2 each time. So after that minus 9, minus 7, it would be a minus 5. So that fourth term should only have 4 blocks remaining. Okay, I'll go ahead then. Number 10. We want to determine if it's arithmetic, geometric, to state if it's a difference or ratio, and then find the next 2 terms. So find basically what we just kind of did up there. Find a pattern to go from 10 to 17, 17 to 24, and so on. Sometimes it's obvious, sometimes it's not. And if it's not obvious, I always just go ahead and make a guess and say, hey, maybe it's arithmetic. And if it's arithmetic, what that means is it should be the second term minus the first term. Whatever number you get there, you want to see if that is going to work for the other numbers that are there. So in this case, if I take 17 minus 10, okay, I get a difference of 7. So I want to see if I keep adding 7, if that gives me that sequence. So 10 plus 7 is 17, 17 plus 7 is 24, 24 plus 3, 1 is, and so on. So this is saying it is arithmetic then. And when we say arithmetic, we say we have a common difference, which in this case is 7. So after 31, plus 7. After 38, plus 7. Now letter B. I can kind of quickly tell that we are not increasing or decreasing by adding or subtracting a number. But what we appear to be doing is changing signs. Anytime I see a changing signs, that means I'm probably got multiplication hiding in there. Multiplication of what? And it then appears to be geometric. And if you just look at 5 to 10 to 20 to 40, that should definitely ring a bell. Now, if you're not seeing that, I always again tell my kids, divide them. 10 divided by -5. Second term divided by the first term, I get a -2. And then I want to see if that multiplication of -2 makes that sequence. -5 times -2 is 10. 10 times -2 is -20. -20 times -2 is 40. It appears to work. That is a common ratio. And then 40 times negative 2 is negative 80. Negative times negative 2 is positive 160. Letter C. Again, I kind of do the same thing. If I can't see it obviously, I just make a guess and say, oh, maybe it's geometric, oh, maybe it's arithmetic, and figure out that special number. Now, right here is where you should maybe have an idea from 27 to 9. 27 to 9, I kind of think in my head is, oh, it's got to be a division of 3. And what I see by that is I can take the second term, always divided by the first term. Now, when you plug it into your calculator, you get a decimal, 0.3 repeating. And that is the same thing as 1/3. Your decimals, so you can change it to a fraction. So we are dividing by 3, or it's the same thing as multiplying by a third, which is then geometric. So go to your calculator and type in 9 times a third. So back to my calculator here. So again, you can just go ahead and say 9 times 1/3. Whoops. And that's where you can see they're telling me it's 3. And then 3 times 1/3. Repeat that. And 3 divided by 3. So replace that 9 as a, if I can find it, 3. 3 times a third is 1, and so on. Okay, letter D. Okay, that one should be, again, fairly straightforward. I can see we're increasing by a 2. And if you're not sure, I always take the second term minus the first term to double check it and seeing if adding a 2 is going to work. And it does. That means we have a common difference. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10.